Bathroom wiring, basic. Compliant with 2020 National Electrical Code, step-by-step guide. How to wire a bathroom. Step-by-step instruction. Bathroom wiring compliant with 2020 NEC, National Electrical Code. Basic bathroom wiring installation per 2020 NEC, National Electrical Code. After watching this video and doing electrical installation work based on it, with a little DIY skills, you will be able to install wiring in accordance with the requirements of 2020 NEC, National Electrical Code, in such a room. This video is a do-it-yourself guide to help you get your electrical work done safely and professionally. Always follow all safety rules and national, state and local laws. Electricity is dangerous. Errors can result in death or serious personal injury and property damage. Always de-energize the circuit before doing any work on it. There are a few circumstances where it is necessary to work on live circuits with extreme safety precautions. If you are not comfortable with this job, hire a professional. Follow national, state, and local codes when wiring your home. NFPA, National Fire Protection Association, codes. NFPA 70 NEC, National Electrical Code. NFPA 1 Fire Code. ANSI, American Nationals Institute. ASHRAE, American Society of Heating, Refrigerating and Air Conditioning Engineers. IES, Institute of Education Sciences, Code. ANSI, ASHRAE, IES 90.1 Energy Standard for Buildings. Steps before starting wiring. Most municipalities require a permit for most types of construction. Do it right and get permission from your local building department and ask about all the requirements for the job to be done properly and safely. Ask about all required inspections. Usually, an inspection is required for rough-in wiring and a final inspection after job is done. To get permission, you need to complete an application and draw up a plan, if you don't have an architect, and submit it to the building department for a review. The electrical plan should show how the bathroom will be wired. The bathroom wiring will be shown under the following conditions: a brand new bathroom in a new home, or a new added room in an existing house, or a gutted room with the old electrical installation removed. The bathroom has door, window, toilet, vanity sink and bathtub. The bathroom has typical wiring required by the NEC, National Electrical Code, Fire Code, Energy Code and other local codes. In the bathroom, the codes require receptacle, switched light outlet with switch at the entrance, exhaust fan, if the window exists. Exhaust fan not required in most municipalities, check local codes. Typical medium-sized bathroom 10 feet by 6 feet which has a door, window, toilet, vanity sink and bathtub. Basic layout 1. It is a brand new room or completely gutted. An electrical plan will be drawn for this bathroom. HVAC air supply vents already installed. Examples of bathroom wiring plans that need to be sketched for the construction department to meet legal requirements. Symbols commonly used on electrical plans that need to be known to draw a plan. GFCI duplex receptacle, light outlet, single pole switch, exhaust fan. To draw a plan, you need to know the basic code rules. Placement of the receptacles. Within 3 feet of the outside edge of each basin and must be located on the wall that is adjacent to the basin or countertop, or located on the countertop or on the side or front of the cabinet and not lower than 12 inches below the top of the basin. Cannot be installed within a bathtub zone, 3 feet measured horizontally and 8 feet vertically from the top of the bathtub rim or shower threshold. Exception: in a small bathroom where the bathtub zone cannot be maintained, you can install the receptacle opposite the bathtub or shower, on the farthest wall within the room. At least one lighting outlet controlled by a listed wall-mounted control device. Exhaust fan if required. Bathtub and shower space zone, 3 feet measured horizontally and 8 feet vertically from the top of the bathtub rim or shower threshold. 3 feet measured horizontally from the top of the bathtub rim or shower threshold, and 8 feet vertically from the top of the bathtub rim or shower threshold. The 2020 NEC does not specify a zone of 3 feet horizontally below the bathtub rim or shower threshold. No any receptacles and any parts of cord connected, cable suspended luminaires, lighting tracks, paddle fans shall be located within a zone. Unless installed as a part of a listed shower or tub assembly, the switches shall not be installed within shower or tub spaces. The 2020 NEC does not prohibit the installation of recessed lighting and exhaust fans in bathtub and shower areas. Installed luminaires shall be marked, suitable for damp or wet location, or when luminaires subject to shower spray shall be marked, suitable for wet location. Recessed light fixtures above a tub or shower do not require GFCI protection per the 2020 NEC. Exhaust fans can be installed anywhere on the bathroom ceiling, but if an exhaust fan is installed above a bathtub or shower, use GFCI protection if required by the manufacturer's installation instructions. Exhaust fans shall be listed for installation over the tub or in the shower area. The 2020 NEC does not require that an exhaust fan installed above a tub or shower be protected by a GFCI, ground fault circuit interrupter, but the manufacturer may require it. Read the label or warning on the exhaust fan, which may state that the exhaust fan is acceptable for use above a bathtub or shower if installed on a GFCI protected circuit. The area around the vanity sink for installing a receptacle outlet required by 2020 NEC. Placement of the receptacles. Within 3 feet of the outside edge of each basin and must be located on the wall that is adjacent to the basin or countertop, or located on the countertop or on the side or front of the cabinet and not lower than 12 inches below the top of the basin. Cannot be installed within a bathtub zone, 3 feet measured horizontally and 8 feet vertically from the top of the bathtub rim or shower threshold. Exception: in a small bathroom where the bathtub zone cannot be maintained, you can install the receptacle opposite the bathtub or shower, on the farthest wall within the room. Single receptacle shall be permitted for an electronic toilet or personal hygiene device. The receptacle shall be readily accessible on wall behind the toilet, not behind the tank, and on the opposite side of the toilet from the shower or bathtub. Example layout of a small bathroom. The bathtub and shower space zone covers the entire bathroom. Exception in 2020 NEC: in a small bathroom where the bathtub zone cannot be maintained, you can install the receptacle opposite the bathtub or shower, on the farthest wall within the room. The walls opposite the bathtub or shower. NEC requirements are met when the receptacle is installed on the wall on that side of the vanity. Examples of basic and most common bathroom wiring plans that should be sketched for the construction department to meet regulatory requirements. Minimum electrical requirements for a bathroom with a window. GFCI protected receptacle on a dedicated 20 amps circuit. Switchable light outlet. 2 wall sconces can also be installed on the sides of the mirror, instead of one light above the mirror, not common. The minimum electrical requirements for a bathroom without a window are the same as above, but the installation of an exhaust fan is also required. Examples of commonly used bathroom wiring. Example 1. GFCI protected receptacle on a dedicated 20 amps circuit, switchable light outlet, exhaust fan connected to a vanity light outlet. Example 2. GFCI protected receptacle on a dedicated 20 amps circuit, vanity light outlet, exhaust fan connected to a separate switch. Example 3. GFCI protected receptacle on a dedicated 20 amps circuit, vanity light outlet, recessed light over the bathtub, exhaust fan. If the municipality does not require an architect's plan, a plan similar to the examples above should be prepared and submitted to the building department for approval. After obtaining the permit, work can begin. The bathroom wiring shown in this video will be based on the bathroom layout examples shown in the plan examples provided. The bathroom is ready to be wired to the minimum electrical requirements for a windowed bathroom in accordance with 2020 NEC. Wiring. Tools and materials. Tools needed to do this job. Any drill with drill bits. Phillip bit. Side cutting pliers. Diagonal cutting pliers. Wire stripper. Flathead screwdriver. Marker. Hammer. Small level. Tape measure. Any ladder. The materials needed for bathroom rough-in wiring depend on the bathroom layout you choose. You will need some materials from the list below. 14. 2 nm, non-metallic sheathed cable. 12. 2 nm cable. 4 inches recessed lighting housing. Or 6 inches recessed lighting housing. Arcanless recessed light, installed after sheetrock installation. Non-metallic 4 inches light outlet junction box with adjustable bar hanger. Or metal 4 inches octagonal light outlet junction box with adjustable bar hanger. Or metal 4 inches shallow, pancake, light outlet junction box. Grounding screw for metal light outlet junction boxes. Push-in cable connectors or similar. 1 gang receptacle switch junction box. 2 gang switch junction box. 3 gang switch junction box. Remodeled light outlet junction box. Listed staples for NM cable. Wire nuts. Nail plates. Cable stackers. Snap-in stud bushing, if metal studs are used. Exhaust fan suitable for bathroom size. The materials needed for the final finishing of the bathroom wiring also depend on the chosen bathroom layout. You will need some materials from the list below. Duplex receptacles. Single pole switches. GFCI receptacle. Junction box extenders. 4 or 6 inches recessed lighting trim. receptacle, switch wall plates, 1, 2 or 3 gang. Vanity light fixture. 20 amps circuit breaker suitable for the panel board in which it will be installed. 20 amps GFCI circuit breaker suitable for the panel board in which it will be installed, if GFCI protection for the receptacle will be made in the panel board. Measurement and marking of the room for wiring electrical equipment. Minimum bathroom wiring required by the 2020 NEC. Minimum electrical requirements for a bathroom with a window in accordance with the drawn plan. GFCI protected receptacle shall be installed within 3 feet from the edge of the sink, no lower than 12 inches from the top of the sink, located on walls, countertop or cabinet, most often 44 inches from the floor, 8 inches from the countertop, to the bottom of the junction box. Must be a GFCI receptacle or the protection of this receptacle outlet must be done in the electrical panel. Must be powered by a dedicated 20 amps circuit. Framed walls of the bathroom, according to the plan. Pre-mark the location of the lighting devices that will be installed in the bathroom on the studs. The plumbing may already be installed. Measure the distance from the floor and mark the bottom of the junction box on the previously pre-marked stud for the receptacle outlet box. 44 inches is the most common distance from the floor to the bottom of the receptacle outlet junction box in the bathrooms. Repeat the same to mark the switch junction box. To mark the outlet junction box for the vanity light outlet, measure the distance from the floor and mark studs near the previously pre-marked spot for the light outlet. The height of the vanity light outlet above the sink is usually 76 to 84 inches above the floor to the center of the junction box. Measure from a wall or other point to mark the center of the vanity light outlet. If the center of the junction box for the light outlet is between the studs, a 4-inch round junction box with an adjustable hanger will be used. If the center of the light outlet junction box is on a stud, a 4-inch round, shallow pancake junction box will be used. If you don't know the exact location of the light outlet, you can leave the cable behind the wall, between the studs, in the expected location, and the junction box outlet will be installed after the wall is finished. If 2 wall sconces will be mounted on the sides of the mirror, measure the desired position of the wall sconces and mark the lighting junction boxes in a similar way. 44 inches from the floor to the bottom of the receptacle or switch junction box. Marking and installation of the exhaust fan from example 1, 2 and 3. Mark the center of the exhaust fan to be installed on the bottom of the ceiling joists, and install the exhaust fan housing. Marking and installation of the recessed light from example 3. Mark the center of the recessed light to be installed on the bottom of the ceiling joists, and install the recessed light housing. Installation of junction boxes. There are many different junction boxes available to suit the installations described above. 4 types of junction boxes were selected that are best suited for the bathroom wiring described above. A non-metallic, nailed Carlin 22.5 cubic inches junction box was selected for the receptacle outlet and switch. For the light outlet above the vanity cabinet, a metal 4-inch octagonal junction box with an adjustable hanger was selected if the center of the light outlet is between the studs. Or a metal 4-inch shallow, pancake, junction box if the center of the light fixture is on the stud. A Carlin 34.6 cubic inches non-metallic nailed 2-gang junction box was selected for the 2 switches. 1-gang Carlin 22.5 cubic inches or similar junction box. A single-gang Carlin 22.5 cubic inches or similar junction box can be used as the junction box for receptacle and switch. Front view of a single-gang Carlin junction box. Side view of a single-gang Carlin junction box. Details of non-metallic, nail-on single-gang junction box. This box requires a wall depth of at least 3 inches. The cable entering this Carlin junction box must be attached to a stud within 12 inches of the box. Box size, volume in cubic inches 22.5 cubic inches. The maximum number and size of wires that can fit in a box, making it easy to calculate. Each insulated wire counts as 1. 4 uninsulated bare wires as 1 and each additional as 1/4. Each device, receptacle, switch, etc. as 2. Example, the number 11.14 on the box indicates that the junction box holds 11 of 14 AWG, American wire gauge, size wires. Example of counting for 3 cables 14. 2 Nm, Romex, 3 white and 3 black wires 3 plus 3 equals 6. 3 bare ground wires as 1. 1 receptacle, switch, etc. to be installed as 2. Total equals 9. This means the box can fit 1 more 14.2 cable to get maximum allowable capacity. This means that the box holds a total of 4 14.2 Nm cables and 1 device. Knockout for the cable entry in the junction box. Nails for mounting the junction box. 1/2 inch mark for standard house walls sheetrock thickness, 1/2 inch thick sheetrock. Markings for different wall finish thicknesses. Mounting holes for electrical devices. To install a nailed junction box. Hold the junction box on the side of the stud and align the bottom of the box with a marking sign on the stud. While holding the junction box at side of the stud, drive the nails of the box into the stud. When attaching the junction box to the stud, the marking on the box for 1/2 inch sheetrock must evenly touch the stud. After marking the location for the receptacle and switch, attach the receptacle junction box and the switch junction box to the studs. Receptacle or switch junction box installed. If necessary, add a piece of wood to move the junction box further away from any wall element, door trim, wall corner, etc., to make enough space for wall plate installation. Vapor-tight junction boxes for external walls may be required to meet energy code requirements. Four inches octagonal metal junction box. 4 inches octagonal metal junction box is used for the installation of ceiling or wall lighting fixture. Junction box capacity 15.5 cubic inches. Number of cables allowed in the junction box must be calculated in accordance with Article 314.16/2020 NEC. Ground screw hole with raised ground screw area. 1/2 inch, or 1/2 inch and 3/4 inch, knockouts, 8 total. Holes in the junction box for mounting it to the surface, 5 total. Junction box ears with screws for attaching the lighting fixture to the junction box. Adjustable junction box hanger. Adjustable metal junction box hanger. The adjustable junction box hanger is rated to support weight of 50 pounds on 16 inches span center. The bar clamp installs in the center 1/2 inch knockout at the bottom of the junction box. The bar hanger adjusts from 14.5 inches to 22.5 inches. Bar hanger clamp. Holes in the bar hanger support straps for the screws that attach the bar hanger to the studs. Bar hanger lock tab. Junction box installed to the adjustable bar hanger. A metal 4 inches octagonal junction box with an adjustable hanger was selected if the center of the vanity light outlet is between the studs. The center of the junction box between the studs. Install a metal 4 inches octagonal junction box with an adjustable hanger between the studs at the lighting location mark, and adjust the junction box on the hanger to the desired center junction box position. Open the center knockout in the octagonal junction box. Remove the screw from the bar hanger slider. Place the junction box on the slider and loosely screw in the previously removed screw. Install the bar hanger with junction box between the studs. Adjust the junction box on the slider in the desired location and tighten the slider screw. Metal 4 inches shallow, pancake, light outlet junction box. Metal 4 inches shallow, pancake, light outlet junction box. Junction box capacity 6 cubic inches. Number of cables allowed in the junction box must be calculated in accordance with Article 314.16/2020 NEC. Ground screw hole. 1/2 inch knockouts, 5 total. Holes in the junction box for mounting it to the surface, 4 total. Junction box ears with screws for attaching the lighting fixture to the junction box. A metal 4 inches shallow, pancake, junction box was selected if the center of the light fixture is on the stud. Center of junction box on a stud. Install a metal 4 inches shallow junction box onto the stud. Select and open the junction box knockout. Attach the junction box to the stud. Carlin 2 gang non-metallic, nail-on junction box. Details of non-metallic, nail-on 2 gang junction box. Box size, volume in cubic inches 34.6 cubic inches. The maximum number and size of wires that can fit in a junction box, making it easy to calculate. Each insulated wire counts as 1. 4 uninsulated bare wires as 1 and each additional as 1/4. Each device, receptacle, switch, etc. as 2. Junction box clamps, push-in, 8 total. Junction box rails for inserting a divider plate between junction box gangs. 1/2 inch mark for standard house walls sheetrock thickness, 1/2 inch thick sheetrock. Nails for mounting the junction box. The nails can be switched to a different driving angle. Mounting holes for electrical devices. 2 gang switch junction box installed. Carlin 3 gang non-metallic, nail-on junction box looks the same as Carlin 2 gang junction box, but has a larger capacity and accommodates 3 devices, for example switches. Box size, volume in cubic inches 52 cubic inches. 3 gang switch junction box installed. Cable installation. Drilling holes. Holes for routing cables through wall studs can be drilled at any horizontal stud height, but are typically located approximately 30 inches to 40 inches above the floor in each stud along the wall if needed. Side view, wider, of 2 inches by 4 inches stud and details of drilled holes. The drilled hole should be no larger than 7/8 inch. Usual drill bit size can be smaller but not less than 1/2 inch. The edge of the hole should be no closer than 1 1/4 inch from the edge of the stud. Drilled hole. 1/16 inch thick steel nail plate. If the edge of the hole is less than 1 1/4 inch from the edge of the stud, secure the hole with a 1/16 inch thick steel nail plate of the appropriate length. For holes greater than 7/8 inch in diameter, a steel plate must be used on both sides of the stud. Cable protection with a nail plate. If necessary, multiple holes can be drilled according to hole drilling rules. In wider studs, The hole may be larger. Any stud can be drilled or bored no more than 60% of the width of the stud. The hole is no closer than 5/8 inch from the edge of the stud, and the hole is not in the same section as a notch or cut. The cable must be protected by a steel plate if the edge of the hole is less than 1¼ inch from the edge of the stud. Stud in any external or load-bearing wall may be notched, but not deeper than 25% of the width of the stud. The cutout with the cable must be protected with a steel plate. The cutout must not be in the same place where the hole is drilled. For the top and bottom plates, the same drilling rules apply as for studs. The top plate of the stud wall. Holes may be drilled in joists no larger than 1/3 of joist width, and at least 2 inches from the top and bottom of the joist to the edge of the hole. For multiple holes, the distance between the holes must be 2 times the diameter of the larger hole. The hole can be drilled at least 1 inch from the end of the joists to the edge of the hole. Holes openings in joists beams. When routing cables through metal studs, a snap-in sleeve must be used in each stud. Installing cables. All cables must be installed and supported in a neat and professional manner so that the cable is not damaged during normal use of the building. Cables installed and run over beams, through studs and in horizontal chases are usually naturally supported. NM, non-metallic sheathed cable, Romex cable. Non-metallic sheathed NM Romex cable shall be supported and secured with staples, cable ties, straps, hangers or similar hardware and installed in such a way as not to damage the cable. Approved supports, listed, for NM cable: staples, cable stackers, cable ties, etc. Requirements for installation and support: NM non-metallic sheathed cable, Romex cable. The distance between the supports shall not exceed 4.5 feet. The support from the enclosures, outlet box, shall not exceed 12 inches. After the cable enters the outlet box, the cable must be approximately 12 inches to 18 inches long after entering the junction box for splicing, cable connection. If staples are used as cable supports, the staples must be approved to support NM cables. The NM cable must be stapled on a flat surface, not on the edge. The NM cable must be stapled on a flat surface, not on the edge. Do not drive the staples too hard into the cables. Staples should be drive tight enough to hold the cable in place, but not so tight as to pinch and damage the cable. Driving the staple too hard can damage the cable. Do not drive the staple over the staple during the stapling another cable in same place. The staple must contact the cable with its flat surface, not a sharp edge. The cable must not be stapled closer than 1¼ inch from the edge of the stud. No more than 2 cables can be stapled with the same staple. Do not damage the cable when removing the staple. If it is not possible to staple the cable, too narrow space, a cable tie or other way of supporting the cable should be used. The low-voltage cable must not occupy the same cable hole as the power cable, it must be run in a separate drilled hole. Cable stackers. The edge of the cable stapled in the center of the 2 by 4 inches stud must be 1 1/4 from the edge of the stud. Otherwise use hangers, stackers, etc. to support this cable. If there are more than 2 cables running along a 2 by 4 inches stud, use cable stackers, etc. to keep the cables away from the stud. 7/8 inch hole for cable. Up to 3, 12 or 14 AWG, NM cables per drilled 7/8 inch hole in the 2 by 4 inches stud. Steel cable protection plate, nail plate. Use a nail plate to protect the cable if necessary. Installation of wiring in the bathroom based on drawn plans. Bathroom wiring meeting 2020 NEC minimum requirements. Cable routing. Minimum electrical requirements for a bathroom with a window. GFCI protected receptacle on a dedicated 20 amp circuit. Switchable light outlet. For better understanding, this plan will be converted and show the location of junction boxes to show the installation of cables between these boxes. Bathroom plan after conversion to show the location of the junction boxes. 14, 2, and 12, 2. NM non-metallic, Romex, sheathed cable will be used for bathroom electrical wiring. Do not mix wire sizes in one circuit. According to the 2020 NEC, 14 AWG cable shall be protected by a 15 amp circuit breaker and 12 AWG cable shall be protected by a 20 amp circuit breaker unless the exceptions described in the code, for example motor loads, are met. The 14, 2, and 12, 2, NM cable contains bare, ground, white, neutral, and black, hot wire. The receptacle outlet will be wired with a 12, 2, NM, Romex, cable and the lighting outlet with a 14, 2, NM cable. To wire the receptacle outlet, run a 12, 2, NM cable, circuit feeder cable, from the receptacle outlet junction box to the electrical panel. To wire the light outlet, run a 14, 2, NM cable, circuit, feeder cable, from the switch junction box to the power source. The power source can be an electrical panel, another switch or receptacle, a light outlet, or any junction box with 14 AWG wires. Run another cable from the switch junction box to the light outlet junction box. When installing cables, the volume of the junction boxes must be taken into account. The cable must be long enough to be spliced, connected, inside the junction box. It should be 12 to 18 inches long when it enters the junction box. If necessary, protect the cable with a nail plate. The sheath, jacket, of the cable should protrude beyond the entrance to the enclosure, electrical box, not less than 1/4 inch. The cable sheath should not cause the junction boxes to overfill. The cable sheath not removed takes up space in the junction box that may be needed for splicing and device installation. To avoid electric shock and tripping of the circuit breaker, make sure that the insulation of the wires, conductors, is not damaged. Cut with a knife when removing the insulation from the wires. Cable splicing. Cables in junction boxes must be spliced before the initial inspection. Splicing is the joining of two or more separate wires, conductors. The grounding conductors must always be connected to each other to form one equipotential bonding. The wire nuts will be used as splicing connectors. All types of wire nuts are listed for a specific number of wires that can be spliced together with a specific type of wire nut. Any wire nut can be used to splice, connect, the ground wires, but a special green wire nut, ground connector, will be used in this example. The green wire nut has a hole on one end that is used to pull one of the bare wires through it, which will become a pigtail on the ground wires to the equipment ground terminals. When splicing the wire, it is enough to make 3 to 5 twists of the wire when the wire nut is tightly screwed on the wire. Do not twist the wire too much up to the cable sheath, as this may damage the insulation of other wires. Separate the ground wires, bare, from the others and push the ground wires towards the back of the junction box. Twist the ground wires. Hold them in your fist. This gives you a minimum length of 6 inches from the box entrance, required, and cut the shorter wire at the front of your fist. Pull the long wire through the green wire nut hole and twist it clockwise. Neatly fold and push the spliced ground wires with the connector into the junction box, leaving the pigtail outside the junction box. When using a standard wire nut to connect the ground wires, add a pigtail that is needed to connect the ground wire to the electrical device. In a multi-gang junction box, you can make a pigtail for each electrical device that is to be connected, for example a light switch. Separate the ground wires, bare, from the others and push the ground wires towards the back of the junction box. Hold the ground wires in your fist. This gives you a minimum length of 6 inches from the box entrance, required, and cut them at the front of your fist. Take a piece of bare, ground wire to make a pigtail and using pliers twist the wires together clockwise. Use a wire nut to secure the connection. Neatly fold and push the spliced ground wires with the connector into the junction box, leaving the wire nut pigtail outside the junction box. A medium-sized wire nut will be used for all other connections. This wire nut can also be used to connect ground wires. A better connection is obtained by twisting the wire with pliers before screwing the wire nut onto the twisted wires. Do not twist the insulated wires too tightly to avoid damaging the insulation. Separate the neutral, white, wires from the black ones. Fold and push the wires towards the back of the junction box. Hold them. Grab them and cut them in front of your fist. Take a piece of white wire to make the pigtail. Strip the end of that wire and also strip the ends of the white wires coming out of the junction box about 1/2 inch. Using pliers and a wire nut, connect the pigtail and other white wires together. Fold the spliced white wires with the connector and neatly push them into the junction box, leaving the pigtail outside the box. Cable conductors colors: bare copper, G, ground wire, conductor. Ground wire may be green or green with yellow stripes in other cables. White, N, neutral wire, conductor. Black, H, hot, power, wire, conductor. Splicing of: receptacle outlet with a cable from the power source, 1 cable. Splicing, connection sketch. Spliced, connected, wires. Cable from the power source. Staple to secure and support the cables no more than 12 inches from the entrance to the junction box. Install the junction box and run the 12-2 cable directly from the panel board. Insert the cable into the junction box, remove the cable sheath, and strip the ends of the wires approximately 1/2 inch. Splicing of: a single pole switch with a cable from the power source and another cable going to the lighting box, 2 wires. Splicing, connection sketch. Spliced, connected, wires. Cable from the power source. Cable to light outlet. Staple to secure and support the cables no more than 12 inches from the entrance to the junction box. Preparation, splicing, of 2 cables entering the junction box to connect the single pole switch. Choose which ones and open the knockouts in the junction box for the cables. Insert the cables into the knockouts in the junction box and staple them within 12 inches from the junction box. The cables should be between 12 and 18 inches long when they enter the junction box. Remove the jacket from the cables. The sheath, jacket, of the cables should protrude beyond the entrance to the enclosure, junction box, not less than 1/4 inch. Separate the ground wires, bare, from the others and push the ground wires towards the back of the junction box. Twist the ground wires. Hold them in your fist. This gives you a minimum length of 6 inches from the box entrance, required, and cut the shorter wire at the front of your fist. Pull the long wire through the green wire nut hole and twist it clockwise. Neatly fold and push the spliced ground wires with the connector into the junction box, leaving the pigtail outside the junction box. Push all the wires, including the pigtail wire, into the junction box, grab them and hold them, then cut them at the front of your fist. Separate the white, neutral, wires from the others and strip the ends of those wires about 1/2 inch. Using pliers and a wire nut, connect the white wires together. Neatly fold and push the spliced neutral wires with the connector into the junction box. Fold the remaining wires and neatly push them into the junction box. Splicing of lighting outlet with a cable from the switch, 1 cable. Splicing, connection sketch. Spliced, connected, wires. Cable from the switch. Wires to the light fixture. Staple to secure and support the cables no more than 12 inches from the entrance to the junction box. Light outlet junction box installed. Install the grounding screw. Install any approved cable connector. Route the cable from the switch and insert it into the connector. Attach the cable to the stud within 12 inches from the cable entry to the junction box. Remove the cable sheath. Wrap the ground wire, bare, around the grounding screw and tighten the screw. Trim the wires, no shorter than 6 inches from the bottom of the junction box, required, and insert them into the junction box. If you do not know the exact location of the light fixture, you can leave the cable behind the wall between the studs, and the junction box for the light fixture will be installed after the wall is finished. Cable for a light outlet left behind the wall. Bathroom wiring based on example bathroom electrical installation plans. Example 1. GFCI protected receptacle on a dedicated 20 amps circuit. Switchable light outlet. Exhaust fan connected to a vanity light outlet. Bathroom floor plan after conversion from a drawn plan to the location of junction boxes. The receptacle outlet, switch and light outlet are wired according to the example from minimal wiring in the bathroom required by NEC. The exhaust fan will be controlled by the same single pole switch that controls the vanity light outlet, but the cable to the fan can be run from the light outlet junction box or directly from the switch. The cable to the exhaust fan runs from the light outlet junction box or directly from the switch. Splicing of lighting outlet with a cable from the switch and a cable to the exhaust fan, 2 cables. The light outlet junction box must be large enough to accommodate all spliced, connected wires. Splicing, connection sketch. Spliced, connected, wires. Splice the cable from the switch and the cable to the exhaust fan by color. Bare to bare, ground, white to white, neutral, black to black, hot. The spliced wires will be connected to the vanity light fixture. Splicing of single pole switch with a cable from the power source or another outlet, a second cable to the light outlet and a cable going to the exhaust fan, 3 cables. Splicing, connection sketch. Spliced, connected, wires. Cable from the power source or another outlet. Cable to the light outlet. Cable to the exhaust fan. Staples to secure and support the cables no more than 12 inches from the entrance to the junction box. Choose which ones and open the knockouts in the junction box for the cables. Insert the cables into the knockouts in the junction box and staple them within 12 inches from the junction box. The cables should be between 12 and 18 inches long when they enter the junction box. Mark the cable coming from the power source. Remove the jacket from the cables. The sheath, jacket, of the cables should protrude beyond the entrance to the enclosure, junction box, not less than 1/4 inch. Separate the ground wires, bare, from the others and push the ground wires towards the back of the junction box. Twist the ground wires. Hold with your fist. This gives you a minimum length of 6 inches from the box entrance, required, and cut the shorter wires at the front of your fist, leaving the longest one. Pull the long wire through the green wire nut hole and twist it clockwise. Neatly fold and push the spliced ground wires with the connector into the junction box, leaving the pigtail outside the junction box. Separate the neutral, white, wires from the black ones. Fold and push the wires towards the back of the junction box. Hold them. Grab them and cut them in front of your fist. Strip the ends of the white wires about 1/2 inch and use pliers and a wire nut to splice the wires together. Fold the spliced white wires with the connector and neatly push them into the junction box. Separate the black wire from the cable from the power source and set it aside. Group the remaining hot, black, wires. Fold and push the wires towards the back of the junction box. Hold them, grab them and cut them in front of your fist. Take a piece of black wire to make the pigtail. Strip the end of that wire and also strip the ends of the black wires coming out of the junction box about 1/2 inch. Using pliers and a wire nut, connect the pigtail and other black wires together. Fold the spliced black wires with the connector and neatly push them into the junction box, leaving the pigtail outside the box. Group all the wires left outside the junction box. Fold and push the wires towards the back of the junction box. Hold them, grab them and cut them in front of your fist. Fold the wires and neatly push them into the junction box. The exhaust fan wiring should be done in accordance with the attached instructions. Splicing of exhaust fan with a cable from the switch or light outlet, 1 cable. The exhaust fan wiring should be done in accordance with the attached instructions. Splicing, connection sketch. Spliced, connected, wires. cable from the switch or light outlet junction box. Secure the cable to the structure no more than 12 inches from the entrance of the wiring compartment. Installation of the exhaust fan housing. The bathroom fan package includes fan housing with blower, fan grill, damper, screws, wiring plate. Instruction. You will also need button-type cable connector or other approved type, wire nuts, mounting screws. Remove the blower from the fan housing. Remove wiring panel from the fan housing. Install the damper and secure with the supplied screw. Install the wiring plate in a way suitable for cable installation and secure it with the supplied screw. Bend out the tabs to fit fan housing against the structure. Install the fan housing to the building structure using appropriate mounting screws. Install the cable connector. Insert the cable into the connector and staple the cable to the building structure within 12 inches from the cable entry. Remove the cable sheath. Cut the wires to the correct length. Wires must be at least 6 inches long, and strip the wires ends about 1/2 inch. Connect the ground wire, green, from the wiring panel receptacle to the ground wire, bare, from the cable. Connect the neutral wire, white, from the wiring panel receptacle to the neutral wire, white, from the cable. Connect the hot wire, black, from the blower receptacle of the wiring panel to the hot wire, black, of the cable. Reinstall wiring panel and secure it with the supplied screw. Reinstall the blower and secure it with the 2 screws provided. Plug the blower into the black receptacle. Install the fan duct. The bottom of the fan housing must be flush with the finished ceiling. Example 2. GFCI protected receptacle on a dedicated 20 amps circuit. Vanity light outlet. Exhaust fan connected to a separate switch. Bathroom floor plan after conversion from a drawn plan to the location of junction boxes. The receptacle outlet, light outlet and exhaust fan are wired as in example 1. The 2-gang switch junction box contains a cable to the light outlet, a cable to the exhaust fan, a cable from the power source and 2 other cables to power another light outlets elsewhere. Cable to the light outlet. Cable to the exhaust fan. Cable from the power source. Cables to another outlets. Splicing of 2 single-pole switches to control the light outlet and exhaust fan. A cable from the power source and 2 cables to another outlets. Splicing, connection sketch. Spliced, connected, wires. Cable from the power source. Cable to the exhaust fan. Cables to another outlets. Cable to the light outlet. Cables supported to a stud within 12 inches of the junction box. Spliced wires to connect a single pole switch to a lighting outlet. Spliced wires to connect a single pole switch to an exhaust fan. Ground wire for connection to switches. Splicing of wires in a junction box for 2 single-pole switches controlling 2 lighting outlets. Route and install the cables. Choose the correct size junction box and install it on the stud. Then install the cable stacker no more than 12 inches from the junction box that will support the cables on the stud in accordance with NEC requirements. Insert the cables into the junction box. Re-describe the cables. Remove the cable's sheath. This junction box will control two different sets of light, can be bathroom light and bathroom fan. Cable description. Cable from the power source. 2 cables to power other outlets. Cable to the bathroom fan outlet. Cable to the bathroom light outlet. Splice all the ground wires and leave a pigtail for the ground terminals of the switches. Splice all neutral, white, wires. Adding a pigtail. Splice the hot, black wires from the cable from the power source and from the cables supplying other outlets. Arrange the wires according to the type and location of the switch, cut them and insert them into the junction box. Spliced wire sets for connection to switches. Wires for connecting a single pole switch for bathroom light. Wires for connecting a single pole switch for bathroom fan. Example 3. GFCI protected receptacle on a dedicated 20 amps circuit. Vanity light outlet. Recessed light over the bathtub. Exhaust fan. Bathroom floor plan after conversion from a drawn plan to the location of junction boxes. The receptacle outlet, light outlet and exhaust fan are wired as in example 1. Splicing of recessed light with a cable from the switch, 1 cable. Splicing, connection sketch. Spliced, connected, wires. Cable from the switch. Spliced wires. Cables supported to a stud within 12 inches of the junction box. 6-inch commercial electric, recessed light installation. Measure room and mark recessed lights location. Nail the light housing to the beams with center on the light can. This is IC, insulated contact, rated housing and can be covered by insulation but need clearance above light can so it not touching any subfloor above. If space between beams is too narrow, trim hanger bars. Install the cable from the switch. Secure the cable to the beam no more than 12 inches from the housing. Strip off the cable cover for about 6 inches and strip off the ends of the wires for about 1/2 inch. Open the junction box and junction box rectangular knockout for NM cables. Insert the cable into the open knockout. Connect the ground wire, bare, from the cable to the green, ground wire of the light fixture. Connect the hot, black, wire from the cable to the black, hot wire of the light fixture. Connect the neutral, white, wire from the cable to the white, neutral, wire of the light fixture. Close the cover of the light fixture junction box and set the light fixture in the desired location. If you don't know the exact location of the recessed light, you can leave the cable behind the drywall between the joists and the remodel type recessed light will be installed after the ceiling is finished. Cable for a remodel type recessed light left behind the ceiling. The 3-gang switch junction box contains a cable to the light outlet, a cable to the exhaust fan, a cable to the recessed light, a cable from the power source, and a cable to power another light outlet elsewhere. Cable to the light outlet. Cable to the exhaust fan. Cable to the recessed light. Cable from the power source. Cable to another outlet. Splicing of 3 single-pole switches to control the light outlet above the vanity. Recessed light over the bathtub and exhaust fan. A cable from the power source and a cable to power another outlet elsewhere. Splicing, connection sketch. Spliced, connected, wires. Cable to the vanity light outlet. Cable to the recessed light. Cable to the exhaust fan. Cable to another outlet. Cable from the power source. Spliced wires to connect a single pole switch to an exhaust fan. Spliced wires to connect a single pole switch to the recessed light. Spliced wires to connect a single pole switch to the vanity light outlet. Ground wire for connection to switches. Splicing of wires in a junction box for 3 single pole switches controlling 3 lighting outlets. Route and install the cables. Choose the correct size junction box and install it on the stud. Install the cable stacker no more than 12 inches from the junction box that will support the cables on the stud in accordance with NEC requirements. Insert the cables into the junction box. Re-describe the cables. This junction box will control 3 different sets of light: vanity light outlet, recessed light, and exhaust fan. Cable description. Cable from the power source. Cable to power other outlet. Cable to the exhaust fan. Cable to the recessed light. Cable to the vanity light outlet. Remove the cable's sheath. Splice all the ground wires and leave a pigtail for the ground terminals of the switches. Splice all neutral, white, wires. Adding a pigtails. Splice the hot, black, wires from the cable from the power source and from the cable supplying other outlet. Arrange the wires according to the type and location of the switch. Cut them and insert them into the junction box. Spliced wire sets for connection to switches. Wires to connect a single pole switch to a vanity light outlet. Wires for connecting a single pole switch to a recessed light. Wires for connecting a single pole switch to an exhaust fan. Bathroom wiring spliced and ready for inspection. After inspection and approval by the competent authority, the final electrical installation can be carried out. Installation of electrical devices. Receptacle installation. Install a GFCITR, ground fault circuit interrupter, tamper-resistant, receptacle if the 20 amps circuit is protected only by overcurrent protection, standard 20 amps circuit breaker, or a standard TR receptacle if the 20A circuit is protected by a 20 amps GFCI circuit breaker in the electrical panel. GFCI TR receptacle. GFCI receptacle front view. Receptacle test and reset buttons. Receptacle yoke. Receptacle mounting screws. Holes in the receptacle yoke for screws securing the wall plate. Removable ears of the receptacle yoke. Receptacle status indicator light. GFCI receptacle rear view. Load terminals of the receptacle covered with a warning label. Line terminals of the receptacle. Load terminals of the receptacle. Grounding screw of the receptacle. Line neutral terminal of the receptacle, silver screw. Line hot terminal of the receptacle, gold screw. Load neutral terminal of the receptacle, silver screw. Load hot terminal of the receptacle, gold screw. Splicing connection sketch. Single cable wires from the junction box. Ground wire, bare. Neutral wire, white. Hot wire, black. Connecting a GFCI receptacle to a single cable. Connect the ground wire, bare, from the junction box to the ground screw, green, of the receptacle. Connect the neutral wire, white, from the junction box to the line neutral terminal, silver screw, of the receptacle. Connect the hot wire, black, from the junction box to the line hot terminal, gold screw, of the receptacle. Insert the junction box extension if necessary. Example of GFCI receptacle connection on a single cable. Make sure the power is turned off. Connect the GFCI receptacle as follows. Ground wire, bare, from the junction box to the ground terminal, green screw, of the receptacle. Neutral wire, white, from the junction box to the neutral line in terminal, silver screw, of the receptacle. Hot wire, black, from the junction box to the hot line in terminal, gold screw, of the receptacle. Attach the GFCI receptacle to the junction box and install the receptacle wall plate. Energize the receptacle and test it for proper operation. Once the drywall has been installed, reinstall this receptacle on the wall finish and provide a box extension if necessary. Tiles installed, gap between junction box and finished face wall greater than 1/4 inch. Bathroom receptacle outlets are not required to be AFCI, arc fault circuit interrupter, protected according to the NEC 2020. Duplex receptacle. Duplex receptacle decora and standard style front view. All receptacles installed in residential applications must be of the tamper-resistant type. Rear view of the duplex receptacle. Receptacle yoke, frame. Removable ears of the receptacle yoke. Holes in the receptacle yoke for screws securing the wall plate. Push-in terminals. The push-in connection is not recommended for receptacles, especially those with high current consumption, due to poor connection, which may cause damage to the device, overheating, burning. Push-in receptacle terminals are designed to accept 14 AWG wires only to ensure proper operation. Receptacle mounting screws. Grounding screw, green. Neutral screws, silver. Hot screws, gold. Splicing, connection sketch. Single cable wires from the junction box. Ground wire, bare. Neutral wire, white. Hot wire, black. Connecting a receptacle to a single cable. Connect the ground wire, bare, from the junction box to the ground screw, green, of the receptacle. Connect the neutral wire, white, from the junction box to the neutral screw, silver, of the receptacle. Connect the hot wire, black, from the junction box to the hot screw, gold, of the receptacle. Insert the junction box extension if necessary. How to properly install a receptacle according to the 2020 NEC standard. Do not connect more than 2 wires to the back of the receptacle. Instead, splice the wires properly before connecting to the receptacle. When attaching the receptacle to the junction box, pay attention to the gap between the top of the junction box and the surface of the installed drywall. The gap between the drywall surface and the top of the installed box housing must not be greater than 1/4 inch. Box extender with attachment screws. If the gap between the drywall surface and the top of the installed box housing is greater than 1/4 inch, a box extension must be installed. The gap between the non-combustible surface around the boxes should not be greater than 1/8 inch. If the gap is greater than 1/8 inch, the drywall must be repaired. The receptacle yoke, frame, must rest on the mounted drywall so that the receptacle can be firmly attached to the junction box. If receptacle yoke, frame, cannot adhere firmly to the drywall face, too large gap between the drywall and the junction box, a spacer must be used between the receptacle yoke and the junction box to properly secure the receptacle. Outlet spacer. Outlet spacer made of wire nut. The spacer is installed between the receptacle yoke and the junction box so that the bottom of the yoke matches the face height of the drywall. The spacer is installed between the receptacle yoke and the junction box so that the bottom of the yoke matches the face height of the drywall. Install a box extension if needed. The gap between the drywall surface and the top of the installed box casing is greater than 1/4 inch. GFCI protection for this bathroom receptacle outlet per 2020 NEC is provided by a GFCI circuit breaker in the panel board. Make sure the power is turned off. Strip the ends of the wires and make loops in the ends of the wire to connect the wire to the receptacle. Duplex TR, temper-resistant, receptacle. Receptacle wall plate. Junction box extender. Remove the screws securing the receptacle. Connect the receptacle as follow. Ground wire, bare, from the junction box to the ground screw, green, of the receptacle. Neutral wire, white, from the junction box to the neutral screw, silver, of the receptacle. Hot wire, black, from the junction box to the hot screw, gold, of the receptacle. Insert the junction box extender into the junction box. Screw the receptacle and install the receptacle wall plate. If there is a gap between the receptacle wall plate and the tile wall, the screws in the receptacle wall plate are too long and need to be cut. There must be enough space behind the receptacle yoke for the longer receptacle wall plate screws. There is no slot in the wall tile for the receptacle wall plate screws. If necessary, shorten the receptacle wall plate screws. Single pole switch installation. Single pole switch decora and standard style front view. Rear view of the single pole switch. Switch yoke, frame. Removable ears of the switch yoke. Holes in the switch yoke for screws securing the wall plate. Switch mounting screws. Push-in terminals. Grounding screw, green. Hot screws, gold. Splicing, connection sketch. A single pole switch outlet have 3 leads, wires, for connection to a switching device. Ground wire, bare. Hot wire to the light fixture, black. Hot wire from the power source, black. Connect the ground wire, bare, from the junction box to the ground screw, green, of the switch. Connect the hot wires, black, from the junction box to the hot screws, gold, of the switch in any order. Switch attached to junction box. When attaching the switch to the junction box, pay attention to the gap between the top of the junction box and the surface of the installed drywall. Same rules and restrictions apply as for a receptacle. Installation of the single pole switch to the wires coming out of the junction box. Pull the spliced wires out of the junction box. Strip the ends of the wires about 1/2 inch and make a loop on the ground wire. If required by the NEC code, install a box extender. Connect the ground, bare, wire to the ground, green, screw. Connect the two hot, black, wires to either of the two hot, gold, screws. Fold the wires. Push them neatly into the junction box and attach the switch to the junction box. Level the switch. Attach the switch wall plate. Connecting two single-pole switches in a two-gang switch junction box. Splicing, connection sketch. Spliced wires to connect a single-pole switch to a lighting outlet. Spliced wires to connect a single-pole switch to an exhaust fan. Ground wire for connection to switches. Connect the ground wire and one set of spliced wires to one of the two single-pole switches. Each single-pole switch in two-gang junction box is connected in same way as single-pole switch in one-gang junction box, described and shown earlier. Switches attached to junction box. Install the two-gang switch wall plate. Connecting three single-pole switches in a three-gang switch junction box. Splicing, connection sketch. Spliced wires to connect a single-pole switch to the exhaust fan. Spliced wires to connect a single-pole switch to the recessed light. Spliced wires to connect a single-pole switch to the vanity light outlet. Connect the ground wire and one set of spliced wires to one of the three single-pole switches. Each single-pole switch in three-gang junction box is connected in same way as single-pole switch in one-gang junction box, described and shown earlier. Switches attached to junction box. Install the three-gang switch wall plate. Installation of lighting fixtures. Splicing, connection sketch. Wires spliced to connect to a lighting fixture. Ground wire, bare. Neutral wire, white. Hot wire, black. Installation of the Brinley 3-light bathroom vanity light fixture. The light fixture package contains light fixture unit, lamp globes, mounting hardware package, light fixture front view, light fixture rear view, wires for connecting the lighting fixture, ground, bare wire, neutral, white wires, hot, black wires, fixture mounting holes for bracket, bracket holding the globe of a lighting fixture, screw for tightening the bracket holding the globe of the lighting fixture, niche in the globe of the lighting fixture for mounting the bracket. Mounting hardware package contains mounting bracket, wire nuts, bracket mounting screw, instruction. Adjustable screws secure the light fixture to the mounting bracket. Decorative nut for adjustable screws securing the lighting fixture. Nut washer. Mounting bracket ground screw. Bracket slots for attaching the bracket to the junction box. Installed light fixture junction box. Screws securing the lighting fixture bracket to the junction box. Ground, bare wire. Neutral, white wire. Hot, black wire. Make sure the power is turned off. Remove the screws securing the lighting fixture mounting bracket. If the slots in the mounting bracket do not match the screws securing the mounting bracket, you will need to adjust the installation of the light fixture junction box. Install the lighting fixture mounting bracket. Wrap the ground wire around the bracket ground screw and tighten the screw. Strip the ends of the wires about ½ inch. Remove the decorative screw nuts and washers from the bracket adjustable screws. Connect the ground, bare, wire of the light fixture to the ground, bare, wire from the junction box. Connect the neutral, white, wires from the light fixture to the neutral, white, wire from the junction box. Connect the hot, black, wires from the light fixture to the hot, black, wire from the junction box. Insert all the wires into the junction box. Insert the fixture's mounting holes onto the bracket screws. Insert a washer on each screw and tighten the light fixture to the bracket using decorative nuts. Open the bracket that holds the lamp globe. Insert the lamp globe. Close and tighten the lamp globe mounting bracket screws. Install light bulbs of the appropriate wattage. Restore power and test the light fixture. Installation of a junction box for a bathroom vanity light fixture installed after the wall is finished. Remodel light outlet junction box. Cable left behind the drywall for light outlet. Remodel light outlet junction box installed. Installation of Carlin B618R remodel round junction box. Carlin B618R remodel junction box. Capacity of the box. Clamping windows. Swing clamps screws. Swing clamps. Holes for screws securing the light fixture or device. This junction box is not a ceiling box, so it is not listed for light fixture support from the ceiling. In the ceiling, this box can be mounted as a junction box or a support of smoke detectors. Smoke detector is not a fixture, only a safety device, so it is acceptable to be mounted on the box. On the walls as per manufacturer and the 2020 NEC, and previous codes, Code Article 314.27, a 1 exception, this junction box can also support the light fixture of 6 pounds or less. Heavier light fixture can be mounted on this box if the light fixture is attached directly to the structure. Long light fixture. Light fixture connection. Studs under the sheetrock. Mounting points to the studs. Mark location of the light fixture junction box. Four inches round, pancake, junction box can be used as a template. Cut opening for the junction box. Pull out the cable installed during rough-in wiring and left behind the sheetrock. Run back and forth box swing clamps screws to make a thread on the clamps, which make installation much easier while tightening the screws securing the box. Insert cable into one of the clamping window. Push excess cable into inner wall and insert box into opening. Tighten screws to secure swing clamps to inside wall. Strip cable jacket. Trim the excess wires and insert wires into the junction box. Install wire nut on the black wire to make hot wire safe if wire will be energized. Installation of recessed light trim. Housing of the recessed light fixture after installing the plasterboard. Recessed light housing front view. Recessed light housing rear view. Install the recessed lighting fixture trim into the housing. Installed recessed lighting fixture trim.
EcoSmart 5 and 6 inches integrated LED recessed light trim. Light trim front view. Light trim back view. For 5-inch housing. Loosen the screws on the torsion spring brackets. Slide bracket toward the center of the trim and retight the screws. Turn off the switch, and clean spackle around the recessed light housing if necessary. Loosen housing can screws. And adjust housing so it is flush with ceiling. Loosen screw, and push socket plate all of way up and tight that screw. Remove safety plug from light socket. Attach light trim to the housing by screwing on light trim base into housing light bulb socket. Compress the springs and insert into the ears on the inside of the recessed housing can. Push trim into the housing until the trim is flush with the ceiling surface.
Installation of a remodel recessed light after the wall is finished. After finishing the ceiling, you can install recessed light remodel housing, or canless recessed light. Cable left behind the drywall for recessed light. Cut a hole in the ceiling and install a remodel recessed light fixture. Recessed light installed.
The box in which the recessed light was delivered includes assembled fixture, junction box with lamp,
wire nuts.
You will also need button-type push-in cable connector or similar. Recessed light fixture junction box can hold maximum 6 of 14 AWG or 512 AWG conductors by junction box fill calculation. Mark light location, cable already installed during rough-in wiring before sheetrock installation. Using template, if was not supplied with fixture, it can be made of. Mark the cutting line for the fixture opening in the ceiling. Cut the opening using sheetrock saw.
You can also use an appropriately sized hole cutter if available.
Pull cable, already installed, from the ceiling. Trim cable if needed. Strip cable jacket about 6 inches. Strip ends of conductors around 1/2 inch. Open junction box cover and open the junction box knockout. Insert connector into the junction box opening. Insert push-in wire connector, supplied with the light, on each wire from the recessed light lamp. Insert ground, bare cable conductor into push-in wire connector of the fixture, ground green wire, and tuck the wire inside the junction box. Insert neutral, white cable conductor into push-in wire connector of the fixture, neutral white wire, and tuck wire inside the junction box. Insert hot, black cable conductor into push-in wire connector of the fixture, hot black wire, and tuck wire inside the junction box. Close junction box cover and select desired lamp color temperature on toggle switch. Insert junction box into the ceiling opening. Rest the one torsion spring on the sheetrock in the ceiling opening. Squeeze the other torsion spring and insert fixture into the ceiling.
Installation of exhaust fan grill. Housing of the exhaust fan after installing the plasterboard. Exhaust fan grill. Install the exhaust fan grill into the housing. Exhaust fan grill installed. Fan grill. After finishing the ceiling, install the fan grill. Squeeze the grill springs. Insert the springs into the slots of the fan housing and press the grill against the ceiling. A GFCI protected bathroom receptacle must be powered by a dedicated 20 amps circuit directly from the electrical panel, and this dedicated circuit must be protected by a 20 amps overcurrent device per NEC 2020. The 20 amps circuit must be powered directly from the electrical panel, and the circuit must be protected by 20 amps overcurrent device. If a GFCI receptacle is installed in the bathroom, the breaker can be a standard 20 amps overcurrent device. To power a circuit cable from an electrical panel using a standard circuit breaker, make sure the panel board is de-energized. Insert the circuit breaker into the breaker slot in the panel board. The circuit breaker must be listed for the type of panel board in which it is installed. Insert the cable of the circuit to be powered into the panel board. Remove the cable sheath and connect the wires as follows. Ground wire, bare, from the cable to ground bar, in sub-panels, or the neutral ground bar in the main electrical panel. Neutral wire, white, from the cable to the neutral bar, in sub-panels, or the neutral ground bar in the main electrical panel. Hot wire, black, from the cable to the circuit breaker terminal. Standard 20 amps circuit breaker installed. Make sure the electrical panel is de-energized. Open the appropriate knockout in the electrical panel and insert the cable connector. Insert the cable into the cable connector and secure the cable to the building structure no more than 12 inches from the cable entry. Remove the cable sheath. Connect the ground wire, bare, to the ground terminal, in sub-panel, or to the ground, neutral terminal in the main panel board. Connect the neutral wire, white, to the neutral terminal, in sub-panel, or to the neutral, ground terminal in the main panel board. Insert an appropriately selected circuit breaker. Connect the hot wire, black, to the circuit breaker terminal. If the bathroom receptacle is a standard duplex receptacle, The overcurrent device, 20 amps circuit breaker, must be a GFCI type or may also be a GFCI, AFCI type that also protects the receptacle cable. A GFCI, AFCI or AFCI, GFCI circuit breaker looks the same, but the purpose of protecting the electrical circuit is different. Always read the breaker information regarding breaker type and amperage found on the breaker label. GFCI, AFCI or AFCI, GFCI circuit breaker with neutral wire pigtail. Breaker handle. Test button. Neutral terminal. Hot terminal. Pigtail wire. Insert the AFCI, GFCI circuit breaker with pigtail into the breaker slot in the panel board and connect as follows. Circuit breaker pigtail wire to neutral bar, in subpanels, or neutral, ground bar in main electrical panel. Ground wire, bare, from the cable to neutral bar, in subpanels, or neutral, ground bar in main electrical panel. Neutral wire, white, from the cable to the neutral terminal of the circuit breaker. Hot wire, black, from the cable to the hot terminal of the circuit breaker. Plug on, PON, neutral circuit breaker type AFCI or AFCI, GFCI. Plug on neutral AFCI circuit breaker connection plug to neutral bar. To use a plug-on neutral circuit breaker, the load center must have a neutral bus that accepts these breakers. The neutral spring clip of the circuit breaker is inserted onto the neutral bus bar. Connect the wires from the cable to the plug-on type circuit breaker in the same manner as to the AFCI, GFCI breaker with pigtail wire. The next video is an example of installing a similar circuit breaker, AFCI 15 amps with a neutral wire pigtail. Cutler hammer AFCI, arc fault circuit interrupter, combination type circuit breaker with pigtail that can be installed in all listed panel boards. Neutral wire of the breaker, pigtail, to be connected to the neutral bar in the panel board. Neutral wire terminal. Hot wire terminal. Test button with circuit breaker status indicator light. On/off circuit breaker handle. Cutler hammer AFCI combination type plug on neutral, PON, circuit breaker that can be installed in all listed, PON, plug on neutral type panel boards only. Pluggable circuit breaker neutral terminal to panel board neutral bar. Neutral, ground bar of the panel board. Plug on neutral bar of the panel board. Make sure the main breaker is turned off. Insert the AFCI circuit breaker in place of the removed breaker. Connect the breaker pigtail to the neutral bar of the panel board. Connect the neutral wire, white, from the cable to the neutral terminal of the circuit breaker. Connect the hot wire, black, from the cable to the hot terminal of the circuit breaker. When using a plug-on neutral circuit breaker, insert the circuit breaker and connect the neutral and hot wire from the cable to the appropriate breaker terminal in the same way. Restore power. Test the circuit breaker for proper operation. The 2020 NEC standard does not require that bathroom circuits be protected by an AFCI protection device, but it does not prohibit it either. The lighting circuit may be powered by a dedicated circuit from the electrical panel or from any other power source throughout the house, such as receptacles, switches, light outlets or other junction boxes containing the same gauge wire, and these circuits are not intended to supply other special outlets in-house in accordance with the NEC, small appliance circuits, laundry room, etc. The circuits to which the bathroom lighting is connected must be able to withstand the bathroom load. Calculations must be made in accordance with the NEC. The lighting circuit can be connected with a wire with a larger cross-section, NM12, but this is more expensive and does not bring any benefits. As per Article 210.12 2020 NEC, bathroom circuits do not require AFCI protection. All other more advanced bathroom plans will be explained in the next video. For more helpful wiring videos, check out this video description. If this video is helpful, please subscribe. Comments are welcome.